Hello. So I did have to end up recording this early. It's Saturday, which means I just uploaded the other episode that I just recorded recently, and I gotta go in a bit, and I haven't ate breakfast yet. So if my mother barges in here trying to get me to eat breakfast, yeah, that would be awkward. Would have to cut that out. Looks like I'm not peaking today. Might be because it's so early in the morning. If my voice seems a little deeper, it's because I just woke up and took a shower, so the morning voice is still kind of in effect. So, yeah, I have this podcast laid out. I just have to remind myself that talking faster doesn't make the time go by quicker, and we should be good to go. Gucci gang, as Lil Peeps. Man, is that guy still relevant, bruh? Man, I haven't heard of him in so long. But yeah, what is he doing nowadays? No idea. Should probably not get involved. I wasn't the biggest fan of that guy ever. I don't know, his music didn't resonate with me. Escada was okay, but yeah, the other songs like Gucci Gang wasn't that great. Didn't understand it. Wasn't my vibe, you know what I'm saying? I wasn't on the wave. But yeah, today's episode is going to be about theoretical physics. Yeah, might not be the most fun when you hear about it, but don't click off yet. It's going to be really fun, I think, and it's going to be really funny. We're going to talk about teleportation, disintegration, what would happen if the Earth was a cube and a ship went over the corner, and maybe some other random stuff, lightsabers, space travel, all these fun stuff, and yeah. Theoretical physics is really cool. I don't remember what, let's see. What was Stephen Hawking? Stephen Hawking was a British scientist. What type of scientist was he? Yeah, he was a theoretical physicist. So theoretical physics is a bunch of math in the universe and the way the universe works and things that we as humans can do with physics and technology, but it's in theory. Because either we don't have the technology to do it now, we don't know how to do something, but yeah, it's really cool. The subject, the field of study is absolutely amazing, and it's so interesting for me, and some of these things to think about. A lot of these, by a lot I mean all of the ones that we're going to talk about right now, the idea came to my mind from just sitting there and pondering it, so that's going to be fun. But yeah, theoretical physics could to some extent be pointless. I have that written there. Lightsabers. Is that ever going to happen? We can theorize as much as we want. But is that ever going to happen? I don't know, man. Probably not for the lightsabers. But theoretical physics could also be the building blocks for the future, such as lightsabers. Maybe it will happen. Maybe I'm just going to eat my words in a few years. That'd be cool. We'll get to why lightsabers would be a problem. But yeah, and that's what we got for theoretical physics. Really cool. Shout out to Stephen Hawking. He worked on a lot on black holes. That's definitely what he specialized in. Theory. Very fun. So, usually my intro takes like 10 minutes. So this one didn't. This one took 3 minutes. Almost 4. We might be stretching it a little bit on this one. Let's hope that I can really get into the nitty-gritty of these things. The first one I want to talk about is, I have written here teleportation, but I think I'm going to do disintegration first. Let's do the cubed Earth one first, because let's start with the least interesting and just get better and better. Actually, let's start with the semi-interesting and then do the least interesting. Let's go in a nice little sine wave. Is that cosine wave? Start up, go down, go back up. So the cubed Earth. So yeah, we're going to run you through some hypothetical here. Assume that the Earth is a cube. Now, if the Earth was actually a cube, we would all be dead, and plants would also probably be dead, and well, everything would probably be dead. If anything on the universe was off by literally the smallest nanometer, we wouldn't be here. Fun, huh? But very positive to start out. But let's just assume the Earth's a cube. Somehow it works out. We're not all dead. We're all living, and we have technology. Now, if this Earth was a cube. Assume, or let's say there's a ship, right? A ship, just like a boat, and it's gonna cross the edge or the corner of the cube, right? It's gonna sail over the corner. Now, what would happen if the boat did that? Would the boat go straight along the corner and then tip over onto the other side and then keep going? Or would the boat just cut through the corner, like through the water, and then emerge out the other side? No idea. And this thing, all right, so those are the two possibilities. I don't know why I ever came up with this thought. I don't know how it got into my head, but it did. And it stayed there for a while. And this is what I think the answer would be. I think the answer for this one depends on how the laws of gravity would work. Right, so if on this cubed Earth, gravity pulled on each edge, or each edge of the cube, or each face of the cube individually, like by itself, then I think the ship would like continue over the edge until it tipped. However, if gravity pulled equally over the entire cubical Earth in a more spherical manner, then I think the ship would go through the corner and onto the other edge, and that would be sick. Would it be sick? I don't know if the ship went through the water, would it even come out the other side? Because that means it went underwater. I don't know, man. Maybe we'd need some new ship technology. Maybe the cubical Earth human beings can figure that one out. And seeing that one went by so quickly, let's talk about some other stuff. The Kid Laroi, mentored by Juice WRLD, new on the musical scene. He just released his album F Love yesterday, I think it was. Yo, fire, absolutely fire. He plays with his voice a lot, so it feels like there's so many different people on the album when it's more or less just him. It's not really a feature album. There's like one or two or three features. Lil Mosey's on there. That song's pretty good, but he plays with his voice a lot. So I think his sophomore album's really gonna solidify him a bit more. See how he really wants to take his style and which he wants to continue with his music. But this freshman album, oh my God, absolutely incredible. I loved it. Every single song on there was amazing. The skits on there, it was 15 tracks in all, 11 songs, 4 skits. And the skits were just voicemails between him and a female. And the entire album was about a toxic relationship in which he was in that he probably should not have gotten in, and wrote the description of the Apple Music. So yeah, that album was really, really amazing, and I definitely recommend it to all the people out there. Rap, hip hop, that's going to be the genres, mostly rap. And Laroi definitely has some talent. His voice fluctuates a lot, like I said, so it's going to be interesting to see where he goes in the future with his career and his music. But other than that, I think the potential is amazing, and I think he's gonna do pretty well in the scene. So yeah, I'm especially mentored by Juice. Legend mentored you. You're probably gonna go do pretty well. If a legend like that could see potential in you, I'm sure that there is definitely a ton of potential in him. So that's going to be absolutely, or that album was amazing, and his career is probably, I hope, will flourish. Shout out to the Kid Laroi. Yeah, other than that, leave a like, subscribe. I just wanted to throw that in the middle right here, If you haven't done that, if you're listening right now, you don't have to wait till the end. Here's 9 minutes in. Make sure you hit that subscribe button. Hit the bell as well, because YouTube doesn't like new creators. Yep. So I'm gonna need those bells to be hit so when I post. Yeah, very fun, very fun, very fun. Leave a like as well. Helps push this. I would like to be pushed. As well as that, share it with everyone you know. All of them. Your friends, your enemies, all of them. So I can get more clout. Yeah. Great pipe. Maybe if you share it with your enemies, it'll change a little bit. Maybe I will motivate them, inspire them to turn over a new leaf or a new tree. I don't know. And it'll help them out. While we're here and talking about dumb stuff, you know what's stupid? Dumbest thing ever, bro. Why are alligators and crocodiles different animals. No, they're not. They really are not. These animal scientists and their naming, I don't understand. How in the world, how do you look at an alligator, do you look at a crocodile and say they're different? Well, you don't. It's a crocodile. Both of them. That's the end of the story, okay? But if you're an animal scientist, this is how you tell, right? Instead of running for your life like a normal human being, no, you get up there close to this green spiky little turd, right? And you take your hands and you look at their snout first, okay? If the snout is shaped in a certain way, okay, it might be an alligator. It might not be a crocodile. If it's a little smaller, the snout, it's an alligator. No, okay, no. But the real way to know, the actual way that these animal scientists with their biggest brains on the planet, in the universe, know that there's a difference between a crocodile and an alligator is this. The fourth tooth on the alligator, not the second, not the third, not the first, not the seventh, not the fifth, the fourth tooth on the alligator sticks out of its mouth. I'm just going to let that one sit there for a minute. No. What? No. What do you mean? What do you mean? My voice is being, I'm holding my voice in a little bit more. This might be why I'm a bit quiet. I don't know, it's morning. People still sleep. I don't know. In the morning, you don't want to open your mouth too much. So here I am. I should drink some water while I sit here and starve. Hydration, Hydra homie. Here we are. Look. So, a crocodile goes into a dental office. Okay? And he has some messed up teeth. His teeth are crooked, just effed up teeth. And instead of giving him dental treatment, the scientist there says, no, you're not a crocodile, you're an alligator. No, bruh. What? No, bruh. What does that even mean? Why are those? They're not different things, my G. Bruh, and this keeps going. Say the red panda, the red fox, and some other red animals. If you look at them, they're not red, they're orange. They are orange. What? Come on, man. How'd you get there? How did you do that? How did you fail so badly? Let's continue with the red panda. Guess what? It's not even a panda. Oh my! It's a lemur or something. Or ferret. Yeah, it's a ferret. Why is it called a panda? It's not a panda. The red panda is not a panda. Can you believe that? God bless America. Man, why? Some genius used his massive brain to look at a cow's teeth and say, I'm going to suck that. I'm going to get milk from that. And genius. Okay, this is what revolutionary looks like. All right, that man or woman that decided that they want milk from the cow udder. And then there's people that put their glasses on, their white lab coats, look at two green spiky turds and say, one's a crocodile, one's an alligator. Why is the brain the smartest and the dumbest organ depending on who it's in? Come on, man. Who looks at something and names it a red panda and it's not even a panda? Why do you exist? Why, man? I don't get it. I don't get why this happens. I don't get why people are like this. I don't understand why people do this. Come on, man. It's so yeah, well, thank you for coming to my TED Talk. Yep. Man, that stuff. Jesus, those animal scientists, man. Stop naming stuff. It's horrible. All right. Let's move on to the next theoretical physics issue here, or theoretical physics conversation here, instead of continuing to vent about my qualms and vendettas against animal scientists. Yeah, so next one we got here is disintegration. Yeah, interesting, huh? So the first thing we're going to talk about is atoms. So what creates or what makes up everything? Atoms, right? That's the smallest thing we know in science. All right, if you're a quantum physicist and you're going to sit there and tell me quarks are the smallest thing we know, screw you. No, atoms are the smallest thing. Why? Because that's what I learned in my science classes. All right, you are wrong, you quantum physicist nerds studying God knows what. If anyone's ever looked into quantum physics, you probably haven't, because everyone that has is they're dead. I don't know, man. Your brain will probably explode. Don't look at quantum physics. If you look at it, your brain will implode. It will blow up. It will be gone. You will be gone. Quantum physics is horrible. I don't understand it. Goodness gracious, man. Anyways, atoms. Atoms make up everything. Back to the topic. I'm okay. Deep breath. You know what I'm saying? Okay. So, everything vibrates. All of these atoms, they vibrate. If you study atoms, even in solids, the atoms are vibrating just a little bit. They're all shaking. They all have some sort of energy. And so, solid, liquid, gas, plasma, every other state of matter, Bose-Einstein condensate, vibrating. The atoms are shaking or moving to some extent. Now, let's talk about cold and the freezing. When something gets colder, say water becomes ice, water vapor becomes liquid, the atoms start vibrating slower the colder they get. Right? So from liquid to solid, the atoms move a lot less when it becomes a solid. And something that gets hot, so the ice goes to liquid, liquid goes to vapor, the atoms will vibrate faster. They'll start moving faster and, escaping more, playing around more, dissipating more. And so absolute zero is a point of temperature in which atoms get so cold that it's completely cold. There's nothing. I think that movement would stop completely. At least this is my understanding of absolute zero, right? And atoms would stop vibrating. So I think that there's my hypothesis. We're going to Google it right after I say it. I think that if atoms stop vibrating, they'll lose their attractive force to one another and just dissipate and just fall apart into what we would know to be disintegration. They would just disintegrate. So what would happen if atoms stopped vibrating? What would happen if atoms didn't exist? Well, nothing else would exist. I just saw that in my Google search. When atoms stop vibrating, there's no more heat. It is as cold as it gets. This new technique uses optical lattice of crisscrossing. Oh, this is possible. Let's see. Quora. Great place. What will happen to an object if somehow the atoms stop moving? Let's see. The vibration of atoms is the atoms moving, and the sum of all their kinetic energy is the temperature. So if you stop the vibration, the temperature of the substance will reach absolute zero, around negative 273.16 degrees Celsius. This is what is done to achieve absolute zero, and the hypothesis used to calculate absolute zero. And when you cool something down, the vibration slows down. Man, so it wouldn't lose its attractive force. It still stay together. I wonder what it just gets really cold then? That's it? Man, well, that ruins that idea. One of my theories to make a disintegration gun this is believing that if the atoms stop vibrating, they'll fall apart. But I think we can still use option number 2. I have 2 theories. One theory was making a freeze gun, a gun that could be so cold that it makes the atoms stop vibrating in any object, and then it just, fell apart. I guess they'd freeze instead now that I'm learning. Yeah, it would just be a freeze gun. I mean, that's still pretty cool. Shout out Mr. Freeze. Been playing Batman again recently, just replaying the story in a harder mode. Batman Arkham Knight. Fire game. Yeah, really enjoying it. I said fire game when I'm talking about ice. Man, so incongruent. The other option is to make a gun, and this one might still work, The other option is to make a gun that shoots vibrations, that certain frequencies of vibrations. And if you, I believe, can shoot your vibrations at just the right way, since everything's vibrating, if you can vibrate it, I don't know, the opposite way or something, then you can rip them all apart. You can just make it split, fall apart. Not the atom split. If the atom splits, well, bad things happen and we get what you call nuclear bombs. Those aren't fun. However, fusing two neutrons together, that makes a lot of energy, and hopefully that's the future. Energy, huh? Crazy things. There's global warming. So maybe we'll have a podcast on global warming, huh? Or should I just say I don't believe in it and never have to talk about it again? Might be the move. Anyways, that's what I think, right? If we make this gun that will shoot these vibrations and the atoms will all stop, yeah, that would be really cool. Now, I might be completely wrong. I wrote this here, although I might be completely wrong and the force would remain even if the atoms stop vibrating, although I can't make sense of that in my mind. So yeah, I still can't. I can't imagine why the atoms would stay together. I guess let's say the electrons, there's what attaching, that's what's causing the bonds between the atoms. So maybe those just wouldn't dissipate even if they stopped moving. They'd stay together. I don't know what would happen to it. Would it harden up more? Because, I mean, if you're freezing it, it gets harder, right? Huh. Man, this is why theoretical physics is crazy. I mean, this is just what comes up in my head. You know what I'm saying? So, man, maybe I should be better at science. Yeah. Now, this teleportation one, I actually don't think this one's wrong in the matter of the theory that I came up with. But doing it may never be possible. We'll see. So, teleportation is actually is merely transportation, just at an extreme, incredible, and extraordinary speed. So that basically just means to move an object from 1 to 2, you have to go through all the decimal points between 1 and 2. So that's just how it is, right? You know, wormholes exist, and we might talk about that in a minute. Right, but even wormholes, it's not teleportation, it's just really fast transportation. You're still going from point A to B, but you still have to go through the middle. You have to travel. And so teleportation is still going to have to travel. There's no way you can get from point 1 to point 2 with just it happening. You're not just going to disappear and appear, right? However, you can emulate this. Like I said, extraordinarily fast transportation. So you go from one place to another, you just kind of dissipate and then reapate. I don't know, man. What's the opposite prefix of dis? Complement? I don't know, man. I guess that's the opposite of dis. Complementipate in another location. Right, so that's what transportation is. And now that we know that, what is the fastest thing we can move? Something smaller. The smaller something is, the faster we can move it, because there's less gravity acting upon it, less force acting upon it, less air restriction, airflow or air resistance, that's what it's called, acting upon it. There's much less going on the smaller something is. If you have what's something big? If you have a water bottle and you threw that as hard as you could at a wall, and you had a, I don't know, man, piece of chocolate, and you threw that as hard as you could at the wall, which one would hit the wall first? The chocolate, because the momentum would probably transfer better, less air resistance from everything, less gravity acting upon it because it's smaller, and it would just be able to travel a lot quicker. The smaller something is, the quicker we can make it go. The easier we can make it go. I mean, you know, airplanes go pretty fast, but have you seen the turbines on that thing? Yeah, they're enormous. So yeah. So teleportation, how do we get something and make it smaller? Would we shrink it? Maybe, but that probably wouldn't work. Living things definitely would die. And rocks and stuff, maybe you could do that, but enlarging it would also be a problem. However, this is the idea that I have, and most scientists seem to agree with when it comes to teleportation. To teleport something or to move it really fast, is going to be this. This is what you do. You have to rip every single atom of the object apart, take them, move them, put it somewhere, and then attach every single atom in the exact same way that you ripped it apart in. That's a lot. Might be a little bit hard to understand. But this is the example I have that may help simplify it. Let's assume that Legos are the atoms and you build a Lego boat, okay? And this example came from one of my buddies, a cousin of mine, who he was arguing with me and saying, well, why would I do that? Just picking up an entire boat and moving it would be a lot faster than if I took one Lego piece and moved it at a time. However, let's assume the throwing thing again. If we threw the entire Lego boat and threw one piece of the Lego, which one would move faster? The Lego. The Lego would move faster than the entire boat if you threw it as hard as you could. Same force on both of them. And yes, moving one Lego at a time or throwing one Lego at a time would, it's going to be longer than if you just took the boat and moved it, or just took the boat and threw it. And also, it would be really inefficient to go move the Lego, one Lego, place it, move another Lego, and rebuild the boat one block at a time, one Lego piece at a time. But this is what the theory is. This is what I'm saying that teleportation would be. Instead of just moving one Lego at a time, this is what you're going to do. You dismantle the entire boat in one swift motion, in literally under a millisecond. And when you dismantle the entire boat, you throw every single Lego piece, none of them attached to each other. You just throw every Lego piece, and then all of the Lego pieces land and come back to form a boat. They just land so perfectly that the boat gets remade. And that would, in theory, be teleportation, just at a faster speed, because atoms can move faster than the Legos still, because it's smaller. Everything's made out of atoms, not quarks, you quantum physicist. Everything is quarks. That's a joke. I'm falsifying information. Yes, atoms are not the smallest thing. I think they're called like zoons or something. I don't know. It starts with Z, I think, which is the smallest like quark we know. I don't know. Things are weird. But yeah. So yeah. Now, in the real world, if you ripped apart a Lego boat, threw every single Lego piece at the same time, would it fall together into a boat again? Practically speaking, probably not, never. Now, I will say, physically speaking, in the term like physics and mathematically speaking, probability-wise, it is possible that every Lego falls in to make a perfect boat again. It is 100,000% possible. Same way it's possible that if you put all your clothes in the laundry, there's a chance that it all comes out of the laundry folded. Yep, very possible, probability-wise. Will that ever actually happen? No, probably not. Maybe. We cannot give up hope, but, probably not. So yeah, that's teleportation, and that's how it would work, and that's how you'd have to do it. How do we do that? No idea. How do we get the energy to rip the atoms of everything apart? Well, at the moment, we don't know how. The only energy we know how to use now is destroying our planet. So, that probably won't work to teleport, because it would require an immense amount of energy to rip the bonds of atoms apart and then reapply them. Now, could a human being or a living thing in general be teleported in this way, if it was possible? This is the question. So say you're a human being and you want to teleport. We got this technology. And so all of your atoms get ripped apart. That doesn't sound painful at all. I don't think it probably wouldn't hurt. Your neurons probably would not at all be able to register what was happening if it all happened quick enough. But yeah. And then, so all of your atoms get ripped apart. You get moved across some tube or something. And then it all gets reapplied and reattached. Every single one of your atoms get put back perfectly. No mishaps. Your nose isn't on your chest. Your ear isn't on your butt or anything. Everything gets attached perfectly, and you come back the way you started. Now, would you still be alive when you come back? That's the question, and that's the problem. because this is where the problem comes in my head. So, the heart beats, right? And one way we get the heart to start beating, not stop. You could stop it. Start beating again is an electrical pulse, an electrical charge, right? The whole clear thing, right? When defibrillator, that's what it's called, and that thing will apply a shock to the body, and it tries to restart the chest, or we compress the heart to get it to start again. Now, if we rip the atoms of the heart apart, it's not beating, obviously. It's not even a heart. It's just a bunch of atoms. So when it comes back together, will your heart start beating again? I don't know. Will there be, in part of the teleportation machine, will it be like a really hard punch to the chest that'll get your heart started again? I don't know. And even after that, will the medulla in your brain just make it work again? Will your brain even work? Your brain's a bunch of electrical signals. Your entire body runs off electrical signals. You're a big, giant piece of technology, to be honest. Your neurons fire with electricity. Your brain kind of tells your body what to do. And it's a bunch of electricity going through you. You got a ton of electricity in you. And I'm sure the water helps to carry that. You're made up of a lot of water, as we discussed in the last podcast. I just uploaded right now. Let's see how far the uploads go. Let's see. Oh, hey, look at that. It's up. Hey guys, watch that. I know you're not here with me right now, but watch it. Thank you. Yeah. Again, subscribe, leave a like, leave a comment, and share it with all of everyone. Yeah? Thank you. Anyways, yeah. So, yeah, would it work? Would you be brain dead when you came out of the teleportation? Would you be I don't know, man. Maybe there's a way to get around that, but I think in general it would stop and you'd come out the other end with heart failure, or you'd be brain dead, or both. And with either of those things transpiring, living is a little bit of a problem at that point, yeah. Well, I mean, I guess if you're brain dead, you're still alive, technically. You're just not living, which would still suck. Yeah. Comas. Man, torture, those things. If you have a loved one in a coma, that would suck. And if you do have one, and you're happening to listen to this, my sympathy and condolences. Hope they wake up. There's always a chance, right? But yeah, those are the three main theories I have. And I also thought of another one while I was going over this. What was it? I think it was when I was talking about disintegration. It was a vibration of atoms, teleportation. Man, I had something else, another idea that came up in my head. I don't think I said it out loud. Maybe I should have said it out loud. What was it? Just teleports, moving atoms, ripping atoms apart. Man, I don't even remember. Oh yeah, nuclear fusion. So that's theoretical physics, right? I don't know, man. That's probably not the thing I thought of. But it's the thing I thought of now. All right. Yeah, fusing two neutrons together makes a ton of energy. That's theoretical physics to one extent, but we're working on figuring out how to do it. And yeah, black holes are also cool. I think I talked about the theory of relativity last time. Oh yeah, we talked about what science didn't know. I wonder if that's the law of relativity yet. Let's Google that. Let's see. When will Albert Einstein's theory of relativity become a law? When will Einstein's theory of relativity become a law of relativity? Short answer, they will never become the law of relativity. That's not what law or theory means in physics. Really? Long answer. Oh my God. Let's read this. Okay. The question misunderstands the relationship between laws and theories in the hard sciences, parentheses, which to be short and sweet, I'll just call, quote, science, end quote. From this point forward, end parentheses, or more broadly between facts and theories, quote, theory, end quote, in everyday English is an educated guess that is an explanation for something. Those guesses need to be tested to see if we can prove them wrong or if they'll stand up to scrutiny. A quote theory, end quote, in everyday English is closer to meaning what we would call a quote hypothesis, end quote, in scientific. Yeah, that's what I learned in science class, that a theory was, this untested thing, which to me it seemed like an hypothesis. It seems like that is indeed what it is. Let's go to dark mode. I use a great extension that lets me make anything dark mode on Google Chrome. Great. Listen, Google Chrome, why do you use so much RAM? You update your can you update your Google Chrome a little bit so that my RAM isn't just obliterated when I use your when I use your application? Thank you, man. Anyways, e.g., the second law of thermodynamics says that entropy, parentheses, or the messy spread outedness of energy, end parentheses, in a closed system always tends to increase, or, at best, remain as it is. It won't decrease without some outside tinkering. That's just telling us how things are. The quote why, end quote, behind this explanation is... The quote why, end quote, behind this is explained in the statistical theory of thermodynamics. Who's going to read that, huh? Theories in science usually start out as hypotheses, and then the hypotheses get tested more and more by the experiment and or empirical observation. If the hypotheses keep standing the test of time, if these experiments and or observations aren't able to poke fatal holes into them, we get more and more comfortable labeling them as theories, which is to say, we get more and more comfortable recognizing these systematic explanations as fact. Parentheses, though all facts in science and therefore in life are provisional, in that we're sure of them but aware of their limitations and are prepared to jettison them in the face of compelling new evidence, end parentheses. Like I said last podcast, science isn't exactly fact, it's just the least wrong knowledge we have at the moment. The way to test hypotheses is via the predictions they make. Good hypotheses, parentheses, or potential theories, end parentheses, won't just explain the stuff we already know about, but they should predict discoveries that haven't yet been made, and testing those predictions is the strongest way of establishing a hypothesis. And it's also possible for an experimental or observational test to poke tiny, non-fatal holes into a hypothesis, in which case, subsequently, the hypothesis can be slightly modified and subsequently retested to see if it... What does subsequently mean? I mean, I know what it means by context, but I don't know the exact definition, and I want to use the word subsequently, after a particular thing has happened afterward. I want to use that word now. Subsequently. What a fire word. Subsequently retested to see if it'll get killed or survive. Theories are the ones that ultimately survive, parentheses, though even these usually get continuously tweaked in teeny tiny ways, end parentheses. So theories in science are both explanations of fact and facts themselves, and sometimes some of the facts explained by theories or laws. So it's just a sometimes thing. It's just a choice. Is this like a dumb animal scientist type thing? God, man, no. Anyways, let's some miscellaneous things. Space travel, theoretical physics-wise, wormholes, sun sails. Hopefully one day we'll do intergalactic travel as humans. So that would be fun. The next thing is lightsabers. Could we make a lightsaber? Now, the last thing I remember on lightsabers is ceramics would have to be used. But I think the problem is light. How do you stop light, right? A lightsaber, it doesn't go on forever, of course, but you can't just stop it. You can't just say, hey, light, stop moving at this point, and the lightsaber is going to extend this far. How does that work? And how's it solid? How do it extends more than the hilt, right? So how do you put so much into its small hilt that just extends and... I don't know, man. Explaining this is a little challenging, but yeah. And along with it, how do you make the lightsaber solid? Let's say you get the light to stop. Sure, the light can go through anything and it'll cut through anything. Wood, me, up this monitor in front of me, like butter, because if it was hot enough, it would, just go through that. But how would, if two lightsabers hit each other, like in Star Wars, make the sound and they'd collide? Would that even happen? I don't know, man. I guess, yeah, we would just have to use ceramics because that's the highest heat capacity thing we know of. Tungsten actually might be higher. I don't know. Ceramics, I think, is not the highest element because ceramic isn't an element. It's a thing we make. And, yeah, I think that's the highest heat capacity thing we have. From the last documentary I heard, I don't know, technology improves quickly, in this documentary that I looked at about lightsabers, yes, was quite a few years ago. But, yeah, so... we'd probably just have to stick ceramics into a hilt of some sort, make it pop out in a really cool, fun way, make the light somehow stop, and make the ceramic get hot enough to go through everything while also being able to collide and somehow making a cool sound in the process, huh? I don't know, will lightsabers ever become a thing? And if they do become a thing, will they replace guns in crime? I don't know. I guess in Britain, definitely. The UK, I think they don't have, or they don't, like, not everyone can just attain guns in the UK, but in the UK, in the UK, yeah, not everyone can attain guns, but so knife crime rates are through the roof, and most of the fatal injuries and fatal violence they get is knives over there in the Britons, which is, I mean, I think their crime rates in general are lower than America, so it's fine. I'm not going to talk about politics. That's too much for me. However, we did somehow, boys and girls, manage to get finished on this podcast. Let's delete this note, close that tab out. So yeah, that is going to be all for this episode of Seriously Funny. A bunch of theoretical physics. I really hope you enjoyed. Some dumb stuff, some funny stuff about alligators. They're all just crocodiles, man. It's just call them crocodiles. They're crocodiles. That's the end of the story. But yeah, again, hope you enjoyed this episode. I will have to be going soon. I'll also have to eat breakfast soon. That's going to be, that's a thing to do. Yep. And yeah. Please leave a like, please subscribe, and hit that notification bell icon. Man, you hear the YouTubers you watch saying this is weird. But yeah, please hit those buttons. I know one of my cousins hit that button. I love you, little man. And I hope many of you also hit that button. Watch my videos, please. Also, if you just subscribe and don't watch, I think it hurts me more than it helps me. And then share it, of course, as always. Facebook, Instagram, Snapchat, LinkedIn, Tumblr, I don't know, whatever the kids are using these days. Throw it up there. Oh crap, I got a text. Big text, okay. We'll have to respond to that. So yeah, that's a text you should probably get going. Yeah, alright. I love you all. Thank you all for listening, and I will see you next time.